Determine which polynomial has a factor of x plus 1. In order to do this, what we need to do is apply synthetic division and determine if there's a remainder. The notes are telling me if my remainder or my final value in my synthetic division is 0, then the divisor is a factor. It means there's nothing left over. If the remainder is any number other than 0, then the divisor is not a factor because there is stuff left over. So what I need to do is set up my synthetic division for A, where my dividend is 3x cubed plus 2x squared minus x plus 2, giving me the coefficients of 3, 2, negative 1, and 2. Recall from yesterday. From there, I want to use, in my synthetic division, the opposite sign of the sign being used in the divisor. The reason for this, which was not quite mentioned yesterday, was that we're checking to see whether or not that is a 0. In other words, giving me a remainder value of 0. So what value of x would make this entire thing 0? Well, that would be the negative 1, just to put that into a little bit of context. So I use negative 1, and then I bring down my 3, and I begin the multiply-add process. Multiply negative 1 times 3, I get negative 3. Add straight down, I get negative 1. Multiply negative 1 times negative 1, I get 1. Add straight down, I get 0. Multiply negative 1 times 0, I get 0. And add straight down, I get 2. So this is my spot for my remainder. If my remainder is anything other than 0, it is not a factor. Okay, so when it says determine which polynomial has a factor of x plus 1, I'm going to assume that it's going to work out with b. But I need to verify it. So my first step is to start with my dividend coefficients. What I'm noticing, however, is there's not enough terms there. I've got 2x cubed minus x. So I'm missing my x squared. So remember, we need to add in the x squared term since it is lacking. Now I'm ready to set up my synthetic division here. I'm going to use the numbers 2, 0, negative 1, and 1. I'm still dividing by the same x plus 1 divisor, so I want to use negative 1 again. And I'm going to drop down the 2. Multiply negative 1 times 2 is negative 2. That drops down a negative 2 when I add. Negative 1 times negative 2 is 2. And when I add, I get 1. Negative 1 times 1 is negative 1. And when I add, I get 0. Since that is 0, that means there is no remainder, which means that yes, b has, so b has x plus 1 as a factor. Okay, so the original question is asking whether or not a given binomial is a factor of a larger polynomial. So my answer to that question is B.